I'm super fascinated to talk about the underlying platform, the world's computer, that's helping customers run these big AI workloads, and talk about how we're also leveraging AI and Gen AI to deliver a better world's computer. AI enables a brand new application to get built. I think that's the most fascinating part about this shift is we're going to see new applications that we've never seen before. And as I reflect on the emergent computing patterns, the one thing that I'm super curious about is this one on multi-party computation.
I spent my first 25 years with Microsoft and I learned so much, which triggered the idea that maybe we should give back. So we're going to have a podcast. My name is Mark Souza. I'm the Chief Technology Officer for Microsoft Asia region. We're going to talk about technology, challenges, and solutions. So please join us. Hello, and welcome to the next episode of Let's Talk Tech. Previous episodes focused on generative AI, and specifically the models itself, performance, optimization, how to use and when to use what type of model. We thought today we'd do something a little bit different, but just as important and maybe even more important. The platform that you run these models on needs to be performant, it needs to be secure, it needs to be reliable. That's why I'm super excited about my guest today. Charumathy Srinivasan is the Corporate Vice President and Development Lead for the Azure Core Platform out of the Indian Development Center. So very happy for my friend Charu to join us today. So welcome, Charu.
Thanks, Mark.
Well, it's great to have you. So let's get started. Thinking about 3 decades, I mean, you and I have been through many technology waves. Client server, we've been through the cloud, the internet, the phone. And now we're at Gen AI, the fastest technology wave adoption in history. How are you as an engineering leader dealing with all these shifts?
What fascinates me, Mark, is the fact that Microsoft remains so consequential. And because time and again, I think we've learned to adapt ourselves and embrace these paradigm shifts. And today, I think more than ever, we are leading this paradigm shift. And I'm super fascinated to talk about the underlying platform, the world's computer, that's helping customers run these big AI workloads, and talk about how we're also leveraging AI and Gen AI to deliver a better world's computer. But to get me started, I'm going to just briefly have you think about how this business case for investing in AI is turning out for our customers. A lot of our organizations who are investing in core technology platforms are looking at the productivity gains that knowledge workers are able to use AI to essentially boost their productivity. Can you imagine 30 minutes of time every day? And for users of CoPilot, this is a reality, which means this is 10 hours a month. And so really fascinating how the return on investment on AI is pretty dramatic. IDC study talks about for every dollar a company invests in AI, they're getting $3.5 back. And so to me, this is fascinating from the perspective of us as engineers. And to talk about that, I really want to talk about what's hard about DevOps today. If you look at the lost productivity because of poor collaboration and switching between tools per person, or the security risks because of flaws in applications and fewer people kind of dedicated to security. And we also see that not all companies are necessarily equipped to realize the power of AI, and these can be missed opportunities. So a big focus, Mark, is for us to really deliver an optimal experience for the developers. And this allows us to provide more time and energy back to teams to really focus on innovation and also really improve the productivity of our technical staff.
I'm sure everybody's happy to see a focus on helping our developers and making sure the platform is secure, which is one of the biggest worries many customers have with respect to implementing AI solutions. So as a leader for many years, leading big development teams and building the world's computer, how are you using Gen AI to help engineer and build the world's cloud?
Yeah, AI is making a huge difference, Mark, for all our teams. Our engineering teams leverage AI ML algorithms to work through many kind of scenarios. I've just picked a few of those as a way to demonstrate the work we're doing. For instance, we use AI to predict hardware issues before they happen. So we really can proactively fix these issues and avoid downtime for our customers. Mark, you and I are very aware of the life-critical, mission-critical workloads customers are building on our cloud. And it's super crucial for us to mitigate any issues, in fact, either as close to when they happen or even predict when they're likely to happen and kind of migrate our workload so that they will not necessarily see the downtime. We're using AI to optimize our resources, them based on demand, like for instance, compute, network, and storage. The placement algorithms are refined because we're doing a better job of resource optimization. We also are using AI and ML models to really spot unusual patterns. For instance, things that could reflect a security threat or a performance issue. I think you talked about fundamentals when you talked about the world's computer. So, are we able to, as an engineering team, deliver better response to like security threats and performance issues ahead of when they happen? We've also been able to automate incident response, diagnosing our issues, improving kind of the reliability of the fleet. And finally, the use case I also want to talk about is how we're able to forecast future resource needs. And this helps us ensure that we have enough capacity without in many ways, over provisioning. And one of the examples I'm going to talk about in more detail is this very fascinating piece of tech that we've built inside the platform. It's called Right Time to Maintain, right? We do realize that when you're building the world's computer, the Azure platform needs to be able to move virtual machines and either from a traffic shaping perspective or from a capacity perspective. And we need to do this without really impacting the customer's workload. So the impact that the underlying maintenance has on the customer's workload needs to ensure that we do not, like for instance, impact the customer's memory performance or their CPU performance. So what we've done is really looked for 4-hour windows with low activity. So we like analyze lots of kind of data to understand, is there a suitable window when we can maintain and hence essentially reduce the performance impact on customers' workloads. So this, I think, is a small example, but it's a very, I think, interesting example of how we want to really have a seamless and non-disruptive way of running our cloud. And this, in turn, kind of allows the customers to run their workloads at very high reliability. The other interesting example is the one where we really want to deliver workload insights to our customers. We want to give them a complete view of their performance and their health, and this allows us to spot any potential issues early on. And one of the things we've done is we've come back with an approach where we really are able to use underlying metrics, right? And we use machine learning to diagnose these issues faster and earlier, and we're able to also correlate their mark with issues in the Azure infrastructure, right? For instance, there may be something anomalous going on in the underlying system, and we want to be able to correlate a workload issue with something that may be going on in the underlying platform. So by being proactive and addressing problems before they happen, we think we can deliver significant impact to our customers. Our customers can depend on us to run their workloads at the highest possible speeds and feeds, but also with the right reliability and the right security.
This is actually very powerful, and I want to just regurgitate it for a second. All right, so people are building models today. We talked about that, and we talked about how we provide tools to help them build models, and you can run the model any place. That decision of where you run your model is as important as building the right customized model itself. And for some of the reasons that you articulated, Charu, the fact that you can buy your own GPUs and buy your own storage, but what you can't just do easily is all the things you talked about. Using AI to proactively monitor hardware, using AI to proactively monitor security to make sure that not only it's set up to be secure, but we're catching things very, very quickly and mitigating things quickly. Along with I didn't even think about it, the right time to maintenance. You have to apply maintenance without interrupting the environment. So the putting on a platform that has scale and reliability is crucial. So I think you did an excellent job of describing that. Thank you. What are you excited about, and what are some of the things you're excited to work on in the future?
I think as I embrace this platform shift myself, one thing that fascinates me is AI enables a brand new application to get built, right? I think that's the most fascinating part about this shift is we are going to see new applications that we've never seen before. And as I reflect on the emergent computing patterns, the one thing that I'm super curious about is this one on multi-party computation. The thing with AI, Mark, is it's going to require customers to build their own models, maybe perhaps custom models, and fine-tune these models with a different data set. For instance, one of the hospital chains in India, they have a disease model that they've built with patient data over the last 20 years. In many ways, this this disease model is their IP. But in order to run this model at scale in a country like India, they're going to have to fine tune this with data from, say, a different hospital chain that has patient data. And when you reflect on the use case, the minute you're talking about patient data, health data, you're talking about privacy. So this entire field of multi-party computation, and I call it secure multi-party computation, is an approach that allows multiple parties to jointly analyze and compute data without actually sharing the underlying data with each other, right? So what I mean by that is you want to be guaranteed that there isn't exfiltration threat, right? The IP, in this case, the model itself needs to be preserved. So the TLDR for us is two or more parties want to share sensitive data running on top of some of their code, which represents their IP. They do not want to share this data for any other purpose outside their organization. So in many ways, secure multi-party collaboration really ensures that, and it helps stop one company in many ways from getting an unfair advantage if another company's data gets exposed. And the reason I think this is super important, Mark, is it really, the need for multi-party data sharing becomes critical because of stricter privacy regulation. We believe that nearly 65% of global populations will be covered by privacy regulations over the coming years. And it also reflects the importance of secondary party data for deriving valuable insights. And more importantly, as I look at Gartner and other kind of trends, this whole field of privacy enhanced computation is going to be a pretty big trend. In fact, we're working with customers in the region, in Asia, to build kind of compute infrastructure that can guarantee secure multi-party computation. And so that's definitely a body of work that I'm super excited about and super engaged in as we speak. And with that, Mark, I just wanted to tell you why I'm so excited about this AI paradigm shift. And I think in the words of Arthur C. Clarke, any sufficiently advanced technology is virtually indistinguishable from magic. And for me, every day that we do work at Microsoft, we're blown away by this incredible transformation. We look at how customers are using AI at scale and how they're really dreaming up new scenarios that we never thought was possible. So in many ways, AI has allowed us to discover the limits of the possible and to go beyond that into the impossible. And I really think we are leading this piece for the world, but I think doing it with a lot of responsibility, keeping in mind kind of the customer at the center of all the innovation, making sure we do that by delivering a very reliable, secure platform.
Excellent. You know, the multi-party computation is exciting. I mean, having the right data, we learned this, we talked about it in previous episodes, into your model is maybe the most important thing that customers can do to ensure quality of the response time as well as performance. And it's hard enough to make that sovereign and protected. And to add multi-party data, it opens up new opportunities for the impact Gen AI can make. And our customers are very fortunate that have leaders like you at Microsoft developing secure, reliable platforms. So thank you for all you do, and it's been an honor to have you join us today.
Thank you for having me on this conversation, Mark.
And thank you to all of you for tuning in to this episode of Let's Talk Tech. Please leave a comment of other topics that you want to hear, specifically around Gen AI or any other topic for future episodes. Thank you again, and we'll see you next episode.